So we're going to continue looking at factoring polynomials by looking for a common factor. Remember, the common factor is the largest term or largest expression that will divide evenly into all of the terms. And we saw that we could do this by taking each term and breaking it down to a product of its prime factors. For example, 2x squared could be broken down. We could break that down to 2 times x minus 4x will be broken down to 2 times 2. That's what gives you the 4 times the x. And then we said we will circle which factors, remember factors are things that multiply together to get what you start with, are common to each of these sets. Each set has at least one 2 in it. Right, the second set has another 2, but we've already circled the only 2 in the first set, so we cannot circle any more 2's, and each set has one x that we can circle. So we have a 2 and an x circled in each set. That is our greatest common factor. Our greatest common factor is 2x. And if you do it this method, then what is left not circled in each set gives you the other factor. There's an x not circled in the first set, minus, there's a minus sign there. There's a 2 not circled in the first set. There's your factors. Remember, factoring is finding things that multiply together to get what you start with. So we changed it from a difference of terms to a product of two factors. And we've said factoring has lots of different applications that you will see as you go through high school mathematics. Sometimes we use factoring to help us solve equations. Sometimes we use factoring to help us simplify certain expressions. Okay? So you will be factoring all the way through high school mathematics. So you need to know how to do this. So that's one way to factor by taking out a common factor. That's one way to get your common factor and your other factor. And then I said you should get to the point where you don't have to do this, but you can look at the terms and figure out what the greatest common factor is. So if we look at question 2 and looking at the coefficients first of 5 and 15, those are both divisible by 5. That's the largest number that divides into 5 and 15. But then we also have a common factor involving the variable b. There are 3 b's in that first factor because b cubed means b times b times b. But there's only one b in the second factor. So because there is at least one b in each factor, you will have a common factor involving b. And we said you're always going to take the power that's the smallest, right? The first term has a power 3 on the b. The second term has a power 1 on the b. The smallest power on the b's is b to the 1, so that is your common factor, 5b. And then we said that you can get the other factor by now dividing each term by the common factor. When you divide the 5's, they cancel. But then b cubed divided by b to the 1, remember you subtract the exponents, keep the base the same. 3 minus 1 is 2, so that's going to be b squared. Then when you divide negative 15 by 5, you'll get negative 3. And when you divide the b's, they will cancel. So there's the factors. Okay? Factoring is finding things that multiply together to get what you start with. And you can always check by doing that step. Actually multiply. If you go 5b times b squared, you will get 5b cubed. If you go 5b times negative 3, you'll get negative 15b. The only way that you might not be correct, even if you multiply it out to get what you start with, is if you didn't take out the greatest common factor. Sometimes it's a good practice to look at what's inside the bracket and make sure that there's nothing else that divides into all those terms. If there is, then you need to take that out as well. That meant you didn't take out the greatest common factor in your first step. Okay, looking at number 3, you've got a trinomial there. We're looking for the greatest common factor. So before we pick out the greatest common factor, you should recognize that there is no variable p for the last term. So that means there are not p's in all 3 terms. Your greatest common factor cannot involve the letter p. because there is no p in that last term. In this case, the greatest common factor will just be a number. The largest number that divides into 6, 9, and 12 would be the number 3. That is the greatest common factor. Right? There are no p's in that last term, so the greatest common factor cannot involve p. So to get what's inside the bracket, again, we'll divide. 6 divided by 3 is 2p squared. Negative 9 divided by 3 is minus 3p. And 12 divided by 3 is positive 4. So there's the factors. Your greatest common factor is 3. The other factor is 2p squared minus 3p plus 4. And if you multiply that out, you'll get what you start with. All right, looking at question 4. All three terms have at least one n in them, and all three terms have at least one p in them. So the greatest common factor will involve n, it will also involve p, but it'll also involve a number, because all three of the coefficients, 2, 4, and negative 2, are divisible by 2. Our greatest common factor here is 2np. Once you establish that there are n's in all three terms, look at what the smallest power on n is, and that comes from that last term, n to the 1. Once you establish that all three terms have p's in them, again, look and see which term has the smallest power of p, which again is that last term, p to the 1. That is your greatest common factor. To get the other factor, we divide. When you divide the 2's, they cancel. N cubed divided by n to the 1 is n squared. P squared times p to the 1, subtract the exponents. 2 minus 1 is 1. You get p to the 1. What will the next part look like, Cheney? You agree with that, Keaton? Good, absolutely. When you divide 4 by 2, you'll get 2. When you divide the n's, they cancel completely. But you have to divide the p squared by the p to the 1, and that's where the p comes from. Right? Now, remember, you got to be able to multiply it out to get what you start with. So it's true that 2np divided by itself cancels, but when you divide something by itself, you actually get 1. You need a minus 1 at the end. Without that minus 1 there, when you multiply it out, you won't get what you start with. So again, it's true if you divide the 2np by itself, essentially they cancel, but what we're really doing is dividing something by itself. When you do that, you'll get 1. You need that minus 1 there so that when you multiply it out, you get what you start with. Same thing with the next one, right? There's 4 terms there. Look at the coefficients, 21, 14, negative 28, negative 7. Those are all divisible by negative 7. The other thing you should recognize is that all 4 terms have at least one L in them, which means your common factor will also involve the letter L. And when you're trying to figure out what power you need to use, it's always the smallest power, which is what, Brock? Huh? Power of 2, yes. Your greatest common factor is negative 7L squared. The smallest power on L is in that last term, which is L squared. To get the other factor, we divide. 21 divided by negative 7 is negative 3. L to the fifth divided by L squared. Remember, you subtract the exponents. 5 take away 2 is 3. 14 divided by negative 7 is negative 2. And when you divide the L's, again, subtract the exponents. 4 take away 2 is 2. Negative 28 divided by negative 7 is positive 4. And when you divide L cubed by L squared, you'll get L to the 1. And once again, when you divide something by itself, the answer is a 1. But in this case, negative 7 divided by negative 7 will be positive 1. You must have that positive 1 there at the end, so that when you multiply it out, you'll get what you start with. Now, I took out a common factor of negative 7L squared. You also could have done this by saying that the common factor is positive 7L squared. And all that would mean is that all the signs would be the opposite. They're both correct. They are both correct. You take out a positive L squared instead of a negative, all that'll change is that all the signs in front will change. They'll be the opposite of what they first were. Again, they are both correct. And when we get to some other types of factoring, you're going to see there are some cases where we want that first term inside the bracket to be positive. Because sometimes after you factor once, you can factor again using a different type, which we will learn about. Right? But for now, it doesn't really matter whether the common factor is positive or negative. Question 6. There's 3 terms there. The coefficients are 5, negative 30, negative 25. Those are all divisible by 5. All 3 terms have at least one x in them. And the smallest power on x, if you compare all 3 of them, is x squared. All 3 terms also have y's in them. And again, if you compare all 3 of them, the smallest power of y is y squared. So that's your greatest common factor. To get the other factor, you divide each term by that common factor. So do that now, and then we'll check it. Are you done, Declan? What do you get? You agree with that, Princess? Yes, absolutely. That's what you get when you divide each term by 5x squared y squared. Okay, any questions on that? All right, question 7. There's no coefficients there, so our common factor, if it exists, will only involve variables. When you look at all 3 terms, they all have at least one a in them. So Brock, what is the common factor involving a? Hmm? Remember, you take the power that's the smallest. Pardon? No, the last term is a, which is a to the 1. So the common factor will involve just a, or a to the 1. Right? What about the b's, Peyton? Right. The first term is b to the 5. Second term, b squared. Third term, b cubed. The smallest power is b squared. So that's your greatest common factor, ab squared. So now you're going to divide each term by that to get the factor inside the bracket. So do that, and then we'll check it. Are you done, Keen?
Yeah.
What'd you get?
7. Oh. Bracket is what a squared b cubed plus a cubed.
You agree with that, Emery? Why do you agree with that? Just because Keen is never wrong? If you multiply it out, you get what you start with. A to the 1 times a squared gives you the a cubed. B squared times b cubed is b to the 5th. A to the 1 times a to the 1 is a squared. This b squared is not multiplied by any b there, so it stays b squared. So the second term is right. AB squared times b would be ab cubed. So yes, Keen guessed correctly this time. Doesn't happen very often, but So, Allie, what do you think the common factor is for number 8? Do you agree with that, Brooklyn Lorenz? Yes. It cannot involve x because there is no x in that last term. So you're just looking at the coefficients. And the largest number that divides into 6, -9, and 3 is 3. That's your greatest common factor. So, Emil, what will the other factor be? For number 8? Pardon? Keep going. You agree with that, Jensen? You need the +1 there. Because otherwise, when you multiply it out, you won't get what you start with. So you need that +1 there. Right? Do number 9 on your own. Number 9. Liam, what do you think the greatest common factor here is? For number 9, what's the greatest common factor? Sorry? W squared? Well, that's what squared means. Is that right, Olivia? Why not? Sorry? That's right. It's 6w squared. Because of the coefficients 12, -18, -6 are all divisible by 6. So you got the w squared, absolutely. There are r's in the first 2 terms, but not the last. So the common factor cannot involve the variable r. There are w's in all 3 terms, and you take the one that has the smallest power. So Jensen, what's going to go inside the brackets? What will our other factor be? Well, you divide each term by the common factor. If you divide 12 by 6, Jensen, what do you get? 2. When you divide w cubed by w squared, what do you get? Can't hear you. Just w. And then the r to the 5th is not being divided by any r's, so it stays r to the 5th. Next term. Jensen, what's -18 divided by 6? -3. W to the 4th divided by w squared is? And then the r cubed is not divided by any r's, so it stays r cubed. When you divide 6w squared by itself, Jensen, what do you get? Right. And because it's a -6w squared divided by a positive, you're actually going to get -1 there. Remember, if you multiply it out, you have to get what you start with. Question? Yeah, when we're done here. Okay. So we're going to go into something different right now. You need to be here for this. Sometimes the common factor is not just a single term, okay? Sometimes the common factor can be a binomial or a trinomial. So I'm just going to copy out part A, again below here. So there are 2 terms here. Remember, terms are separated by a plus or a minus. There's your first term. Then you have a plus sign, which separates the first term from the second term. There are 2 terms here. Terms are separated by a plus or a minus. Now, it's true that this first term actually has two factors. 3x is the first factor, x minus 4 is the second. Factors are things that multiply together. Same thing with the second term. There are two factors there. 5 is the first factor, x minus 4 is the second. There is a common factor here of x minus 4. Each term has a factor of x minus 4, right? There's one after the 3x, and there's one after the 5. So that is our common factor in this case, x minus 4. To get the other factor, you divide each term by x minus 4. So if you take this first term and you divide it by x minus 4, the x minus 4's will cancel, and you're just left with 3x. When you take the second term and you divide it by x minus 4, again, they will cancel, and you're just left with plus 5. There's the factors. Sometimes the factor is a binomial. Sometimes it is a trinomial. Okay, Brody? So on the next page, there's some like that, where the common factor is a binomial. Okay, Jan? So this first one, once again, there are two terms. There's the first term. There's the second term. The first term has two factors. 2 is one factor, a plus 5 is the second factor. The second term also has two factors. A is the first factor, a plus 5 is the second. Both of those terms have a factor of a plus 5. That is our common factor. To get what the other factor is, once again, you divide each term by a plus 5, and in each case they cancel, and you are left with 2 minus a. Right? This is, I know it kind of looks like a 9, but it is an a. There's your factors. Sometimes the common factor is a binomial or even a trinomial. So looking at the next one beside it, Riley, what's the common factor there? N minus 1 is correct. And what will the other factor be? 3n plus 2. Okay? So you see, in that first one, each term has a factor of a plus 5 in it, so that's our common factor. The second one, each term has a factor of n minus 1 in it, so that's our common factor. What about the next one there? Keaton, is there a common factor there right now? This one right here. No. Jan? 3 minus p. Yeah, I know it doesn't look perfect. It's 3 minus p. So yes, there is no common factor there right now. Couple things. Number one, the terms are in different order. Like here, the p is first, the 3 is second. Here, the 3 is first, the p is second. We could rearrange them, but the sign in front of each term must stay with that term. So the p is negative and the 3 is positive. If you rearrange the terms, that's what it looks like. It's not the same as what's in that first term. Princess, put your phone away. But in this case, we can actually make them the same, all right? And here's how we would do this. We would take out a common factor out of that second term, a common factor of negative 1. So here's what this looks like. I've got the plus 1 already. It's there. I'm going to take out a common factor of negative 1 out of the negative p plus 3, a common factor of negative 1. To get the other factor, you would divide each term by that common factor. Negative p divided by negative 1 is positive p, and positive 3 divided by negative 1 is minus 3. By taking out a common factor of negative 1, now we have made those two the same. So now we can take out a common factor of p minus 3. We've made it so each term has a p minus 3 in it. And when you divide the first term by p minus 3, they cancel. You're left with 2p. When you divide the second term by p minus 3, they cancel, and you're left with 1 times negative 1, which is minus 1. There's your factors. There's your factors. Okay, so this leads us into a new type of factoring called factoring by grouping. So let's back up now, and let's look at question B from this page. Let's look at question B. This factoring by grouping is used when you have 4 terms and there is no common factor among all 4 terms, like this one, right? The first 3 terms have y's in them, but the last one doesn't. The second and the fourth term have x's in them, but the first and the third don't. The last 3 terms are divisible by 2, but the first one isn't. There is no common factor between all 4 terms. But what we can do in a situation like this is called factoring by grouping, where you group the first 2 terms together. So I put a bracket in front of the y squared, a bracket directly after the 8xy. And I'm going to group the last 2 terms together, but notice I'm leaving that plus sign in between the brackets. To make this work, we always want to have a plus sign in between the brackets, and there was already one there. It just depends where we place that bracket. So you see, I replaced it between the plus and the 2y. So I'm grouping the first 2 terms together and the last 2. Now, I will take out a common factor out of each group. In the first group, what's the common factor, Keen? In the first group. What is the common factor between these first 2 terms? What is the common factor between those first 2 terms? Jan? Because I asked you, that's why. No. The common factor is y. That is correct. And if you divide each term by that common factor, y squared divided by y is y. 8xy divided by y will give you 8x. So a common factor of y out of the first 2 terms gives us that. Riley, what's the common factor out of the second 2 terms? You're comparing 2y and 16x. So what's the biggest number that divides into both 2 and 16? Divides into both of those. Or what can you divide them both by is another way of looking at it. Can you help her, Brody? Just 2. The first term has a y, the second term has an x. They both don't have the same variable. So your common factor here is 2. Now, it is a positive 2. So I'm going to put a plus 2 there. When you take out a common factor of 2 out of those last 2 terms, Ava, what are you left with? When you take out a common factor of 2 out of these last 2 terms, what will be inside the bracket? What will our other factor be? And now this, I'm sorry, you said 8x, right? And now this looks just like what we did above. We have 2 terms. There's your first term. There's your second term. Both of those terms have a factor of y plus 8x. So now it's just like the one we did above. There is a common factor here of y plus 8x to take out. That's our first factor. Sophia, what will our other factor be? If you divide this whole thing by y plus 8x, they cancel, and you're just left with what? That's right. There's the factors of the original expression that contained all four of those terms. Now remember, factoring is finding what multiplies together to get what you start with. If you were going to check this by multiplying, you would use a distributive property. The y would be multiplied by the y plus 2, and the positive 8x would be multiplied by the y plus 2. If you multiplied the y's together, you'd get y squared. That's that term right there. There's your y squared. The y times the 2 is positive 2y. That's that term right there. The 8x times y is 8xy. That's that term right there. And the 8x times 2 is 16x. That's that term right there. It checks. You can always check by multiplying. Okay? So, we're going to factor these by, again, grouping. In each case, if you look, you're going to see there's 4 terms. For this first one, there is no common factor for all 4 of those terms. So, we will do this by grouping. We'll group the first 2 together, and then we'll group the last 2 together, and we'll do it in a way so that there is a plus sign in between the brackets. If you remove the brackets, you've changed nothing. A plus sign in front of a bracket changes nothing when you remove the bracket. So we haven't changed anything. And then we look for a common factor in each group. So Cherry, for those first 2 terms, what's the common factor? For the first 2 terms, what will the other factor be? When you divide each of those terms by y, what will you get? It's the same question as the last one. Yeah, it's exactly the same. But you're going to get y plus 8x. And then in the second group, there's a common factor of positive 2, which also gives us y plus 8x. You have a y plus 8x in each term. When you divide by that, you'll get y plus 2. So yeah, it was the same as the last one. I need to change that for next time around. Whoops. But let's look at this next one. There are 4 terms there. In this case, there actually is a common factor amongst all 4 terms. It would just be positive x. So if you take out a common factor of x, you're going to get 2x plus 6y plus 3x squared plus 9xy. But we still have 4 terms there. And so to factor this further, we're once again going to have to look at doing it by grouping, where you group the first 2 terms together, and you also group the last 2 terms together, but remember you want to do it in such a way so that there's a plus sign in between the brackets. So we cannot forget about this common factor of x that we took out at the start. Can't forget about that. That's got to be one of our factors at the end. In the first group, what is our common factor, Chloe? 2. And if you take it out, what will the other factor be? If you divide each term by 2, what are you left with? Okay, good. In the second grouping there, Kai, can you tell us what the common factor is for this second group of 2? What about variables? Are there variables that are common to both of those terms? X. There's an x squared in the first term. There's an x to the 1 in the second. Remember, take out the smallest power, which is x to the 1 or x. Okay, so that is our common factor for that second group of 2. If we take it out, Jensen, what have we left inside the brackets? What will our other factor be? Can't hear you. I'm sorry, I still didn't hear you. Did you say 6? No, because you're going to go 3 divided by 3, which cancels. X squared divided by x is just x. Plus 9 divided by 3 is 3. When you divide the x's, they will cancel. Technically, there's a 1 there, but multiplying by 1 doesn't change anything. You're multiplying by 1. Doesn't change anything, so we don't really need it there. But you also have to divide the y by no y's, which leaves us with y. And once again, I've got 2 terms here. There's the first term. There's the second term. Each term has an x plus 3y in it. So I've got this first factor of x at the start. Then I've got x plus 3y as a common factor for what's inside the big square brackets. If I divide both of those terms by the x plus 3y, they will cancel, and you're left with positive 2 and a positive 3x. There's the complete factors. Okay? Take out your earbud. I shouldn't have to tell you this every day, right? Okay. Look at this next one. Yes, ma'am. No, because they took out a common factor of 3x. There is only one x here. There's a 2x plus 6y, and there's a common factor of 2 between these two terms. I took out a common factor of 3x out of the second 2 terms, which also gives us an x plus 3y. Are we good? Okay. Yes, Jan. Because it's one of your factors. You have to be able to multiply out your final factors to get what you start with. So we took out a common factor of x to begin with. That has to be one of our factors. If you don't have that x in the front and you multiply it all out, you won't get what you start with. You won't. Okay? You won't. Looking at this next one. Again, there are 4 terms. You cannot divide them all by the same coefficient. Only the first and third terms have a's in them. Only the first and second has x's in them. Only the second and third has b's in them. Only the last 2 have y's in them. So there is no common factor amongst all 4 terms, I should say. So we're going to do this by grouping. Now remember, you always want to group them in such a way that there's a plus sign in between the brackets. If you group the first 2 terms together, put them in brackets. All the ones we've done before, there was a plus sign between the second and third term. Here there's not. But we always want a plus sign to be between the brackets, so I'm going to put a plus there, and then I'm going to copy the entire third term, the negative 3ay plus yb, down into my second set of brackets. We haven't changed anything. Remember, a plus sign in front of a bracket changes nothing. So if I remove the brackets, I will have exactly what I started with. And now we're going to take out a common factor out of that first set. What would that common factor be, Brock? I really think that it would help you if you copied down the notes. That is an expectation. You're right, but you need to copy down the notes. That is an expectation. Okay? So can you do that or not? Okay. Thank you. Common factor of 2x. Take it out. When I say take it out, I mean, what do you get when you divide each term by the common factor? So what do you get there, Peyton? Excellent. Now, remember, we need to take a common factor out of the second group, and we must have the same thing inside the bracket after we take out the common factor. In that first group, we took out a common factor of 2x, and inside the bracket, we got 3a minus b. Whatever common factor we take out, we have to get 3a minus b inside the second bracket. Okay, Brody? What would that be? You need to stay with us, okay, please? Kenzie, can you help? Can you tell us? Well, when you look at those last two terms in that second set of brackets, Kenzie, what do you think the common factor would be? Okay, well, if you look at the first term, it's negative 3ay. The second term is just yb. There is no number in front of the yb. So our common factor will not involve a number. All right? Are there y's in both terms? Sure. So the common factor will involve the letter y. Are there a's in both terms? No. So it won't involve the letter a. Are there b's in both terms? No. So it won't involve the letter b. Only the letter y. So don't copy this down. Just watch this. If we took out a positive y as a common factor, can you tell us, Kenzie, what would be inside the bracket? Well, if you divide each term by positive y, what are you left with? If you go negative 3ay and you divide it by positive y, what are you left with? Liam, can you help her? Yes, sir. So what would you write? That would be correct. Now, is that the same as what's in the first bracket? No. Remember, we need the same thing in both brackets. So that tells us that instead of taking out a positive y, we actually should have taken out a negative y instead. And that's why I said, don't copy this down yet. We're going to take out a negative y instead of a positive y, because now you will get 3a, you will get 3a minus b. Remember, you need the same thing in both brackets so you can do the next step. There's two terms there. Both have a 3a minus b factor in them. Take it out, and you're left with 2x minus y. Now we're done. And remember, you can always check these by multiplying. So here is our check. If we were going to multiply these out, we would again use the descriptive property, which we have done many times when we did our multiplying polynomials. Brooklyn, when you multiply 3a by 2x, what do you get? When you multiply the 3a by the 2x, what do you get? These first two. Right, there it is up there. There's that term. We're not done, Brooklyn. You did that so well, you get to do the next one too. If you have positive 3a times a negative y, what does that give you? Yes, you do. You're just being silly. Well, let's do it step by step. The coefficients, 3 times 1 is 3. A times negative y would be negative ay. So you're going to get negative 3ay. That's that term right there. Negative b times 2x is negative 2xb. That's that term right there. And negative b times negative y is positive by or yb. That's that term there. You can always check by multiplying. Always. To make sure your factors are correct. So these are the factors. Factors are things that multiply together to get what you start with. And we just check them to show that they work. Okay? All right. So this next page, page 28 and 29, they are both need to be done and due for marks. I think on yours they're probably 27 and 28, right? So you're going to hand this in for marks. Both sides. What the who?
I'm gonna die.